Hi everybody, it's Mrs. Shiro. Today we're going to be seeing if we can make a energy foldable to show you endothermic and exothermic processes. So we're going to start with our paper like this. You can use a blank paper or you can use line paper. It doesn't matter which one you use. And we are going to start with our paper in landscape format. And the first thing we're going to do is we're going to fold both sides over. So let me quickly do that and show you what that looks like when you're folding. You want to make sure that you are leaving about an inch of space in between the two sides. I guess mine is a little bit more than that, maybe more like an inch and a half to 2 inches of space in between. So here is what mine looks like. I have a flap on this side and a flap on this side. Next we're going to do is we're going to add our title, and our title is going to be endothermic versus exothermic. So I'm going to write the endothermic word on the top of the left hand flap, and I'm going to write VS for versus in between, and I'm going to write the exothermic word on the top of the right flap. So when you look at it, you will be able to see that we have endothermic versus exothermic as our title. Okay. The next thing that we need to do is in that center section that we have not folded anything over, we're going to draw two ovals, one above the other. So you are going to want to have two ovals that look like this. Okay. Next thing we're going to do is we're going to add a line to connect our two ovals. And so what it's going to look like, as you're going to see, is a beaker. Okay. So there's our beaker. The next thing we're going to do is we're going to add some water and a thermometer to our beaker. So go ahead and draw a line for your water, and go ahead and draw a thin tube looking thing for your thermometer, and label that thermometer. So when you go back to look at your picture later, you'll understand, oh, that's the thermometer. Okay, so this is what my drawing looks like at this time. It is a thermometer. Okay, so before we go any further, we are going to, also still working in the center, we're going to label this the system, and we need to make sure that we understand that the system is the actual molecules of water inside there. So I'm going to draw myself a couple of water molecules, as you're going to see, and I'm going to draw an arrow from system to those water molecules so you can see it. I'm about to put it up so you can see what that looks like. So as you can see, I have made the system with the molecules being the system and an arrow to those little molecules, just like that. All right. Anytime you feel like you need to pause this video so you can get it written down on your own paper, that is fine. I am going to continue now by labeling the left-hand flap with an arrow pointing towards the beaker and the word heat over the top of the arrow. So heat, in other words, is going into the system. And before I go on, I'm also adding the word surroundings on the outside. So in this case, heat is coming from the surroundings and going into the system. If this were a chemical reaction, heat would be being used as a reactant. All right, we're going to repeat this, but the opposite way on the exothermic side. On the exothermic side, we're drawing an arrow coming out away from the beaker with the word heat over the top of it and the word surroundings down below. Okay, so in this case, our heat is coming out of the system and going into the surroundings. Now, a little bit of comment about the, how to get it straight, there we go. All right. So much trouble here. I apologize for it being crooked. Comments about what is the system and what are the surroundings. The surroundings is everything else outside of the molecules that we're talking about. So if we're talking about this water here, the system is the molecules and everything else, the beaker, the thermometer, our hand holding the beaker, everything else you can imagine, those are the surroundings. if we're talking about a chemical reaction, then the surroundings is everything that is not part of the reactants and the products. So, as I've said before, if I have an endothermic, this side is endothermic, if I have an endothermic reaction, then we have the heat going in, so heat is being used as a reactant. If I have an exothermic reaction, there's exothermic right there. If I have an exothermic reaction, then heat is being produced or coming out of the system into the surroundings. So heat is a product then. Okay, so once you've got all of that, now we're going to start writing what goes underneath each of our, underneath the endothermic flap is a list of things that we need to know about endothermic reactions. In an endothermic reaction, heat is absorbed by the system and lost by the surroundings. The temperature of the surroundings decreases as a result because the system is taking the heat from the surroundings. As a result, it feels colder, and the heat and the energy of the system are both increasing. One thing I forgot to add on my list that I'm going to add right now is that number 5, heat is a reactant. So we should have 5 things written on our list. So let me get it to where we can see. Boy, I suck at this. Let me get it to where we can see all of it. Heat is absorbed by the system and lost by the surroundings. The temperature of the surroundings decreases. It feels colder. Heat and energy of the system increases. And heat is a reactant. All right. So we're going to repeat that same thing, but for the exothermic side of things. All right, getting it straight now. On the exothermic side of things, heat is released by the system and it goes into the surroundings. And as a result, the surroundings, where we take the temperature, the surroundings temperature goes up, so it feels warmer. The heat and the energy of the system decreases, though, because the heat is being released into the surroundings. And finally, we can say heat is a product. Okay, so when you are doing this foldable at home, you will have a foldable that you have made with all of the important details on the inside. And I'm going to try to get it right here so you can see it, with all of the important details on the inside so that you can show me, aha, I took those notes, Mrs. Shiro. Take a picture of what you made for your foldable and be sure that you are posting that as your submission of, yes, I did my notes. All right, thank you, everybody.